Hi everybody. In section 10.4 we're looking at rotations, and we will be making some constructions and identifying rotated figures. So let's define rotation. It is a transformation by which a figure is turned around a fixed point to create an image. So you see on the right here we have triangle ABC being rotated about point A to achieve the image of A prime, B prime, C prime. Okay, so let's define center. It is the fixed point that a figure is rotated around. And one note here, the counterclockwise direction is the positive direction, and counterclockwise would be negative. So let's take a look at example 1. We are given a regular hexagon. So what do we know about a regular hexagon? Well, regular means it has congruent angles and sides. And for a hexagon, it has 6 of these. That means it has 6 radii that go from the vertex to the center. So there are 6 radii, and there are 6 congruent angles in the hexagon, so that go from the vertex to the center to the adjacent vertex. So if there are 360 degrees in a circle and we divide these by 6, because there's 6 congruent angles, that gives us 60 degrees. So if we rotate point C 60 degrees about O, we will end up at D, point D. If we rotate E 120 degrees about O, remember we're going counterclockwise, we end up at point A. And name the image of F for 300 degree rotation about O. Well, 300 degrees brings us to E. If we did 360 degrees, we'd end up at the same point. So in example 2, we're going to follow the same steps. We have 360 degrees divided by 5, because there are 5 congruent angles. That gives us 72. So if we have G and we rotate it 144 degrees in the positive direction around O, we end up at I. If we're starting at I and we're going 288 degrees about O, we end up at H. And the last one here, we have a negative rotation. If we're at I and we go negative 72, we go clockwise around O, we are at H. Okay, so that's it for those 2 examples. For the next part here, we're going to do a construction, and we need to do this by hand, so I have to switch up my videos here. So we have some rules, and we'll just go over it here in 2 seconds. Hi everybody. Okay, so this is the next part of our video on rotations in 10.4. In this section, we have to do a construction. Okay, so we have some tools that we need. We need a pencil, we need a protractor, and we need a compass. So the rules for our rotation are this. So we're going to rotate a figure through x degrees about point O. So the image of O is itself, because that point of rotation, because that is the point of rotation. For any point W, segment OW should be equal to segment O prime W prime, which is equal to segment O double prime W double prime. And the measure of angle WOW prime is the angle x degrees. Okay, so what does this all mean? So I have a figure, quadrilateral, OXYZ, and I want to rotate this figure 120 degrees about O. So remember, the positive direction is counterclockwise. So this direction is positive. So what I want to do is I want to use my protractor here to find this angle. So x O and X prime, which is going to be over here somewhere, needs to be 120 degrees. So our center rotation is 0, so we put our center of our protractor here at 0, and we have to line up the 0 degrees here through X. So I need to start at 0 and count to 120. So we'll make sure we use the correct side of the protractor for measuring. So we're starting at 0, we go 10, 20, 30, all the way to 120, which is here. And then I can draw a line. It doesn't have to be too thick. I don't want a heavy line here. So X prime is somewhere on this line because this is 120 degrees right here. Just measured it. That's 120. So X prime needs to be equidistant to the point of rotation as X is to the point of rotation. So this is when we use our compass. So I'm going to measure this distance here between the center and X. And then where it intersects is X prime. So this is X prime. Okay, so now I need to do Y and I need to do Z, and then I'll get my new quadrilateral, rotated quadrilateral over here. So I have my pre-image, I rotate the pre-image 120 degrees, I get my image. So I'll do Y now. It might help me to put a little bit of a line in here so I can see it when I'm measuring. So I put the center through the protractor at the center of rotation, line it up at 0, and measure 120 degrees. Then I'm going to put another line here, light line. We're going to end up erasing this one. And now I'm going to measure 0. I'm going to measure OY, this length right here, O to Y. And then I'm going to come over here and put a little arc across my line. It's 120 degrees, and this is Y prime. Now I do the same. I need to measure ZO Z prime as 120. If you need to extend the line to help you see the angle, that's a good idea. 120. Okay, measure the distance. Okay, and there it is. That's Z prime. So now I can connect my points here a little bit darker. There it is. And I can get rid of the extra line here. Okay. Now, that's part 1. So in the next part, I want to rotate O prime, X prime, Y prime, Z prime, that's this figure, 120 degrees about O prime. So this is O, and since it's rotating on itself, I can also call this O prime. It's the same point. Okay, so we're going to rotate it still in the positive direction, 120. So I'm just going to repeat these steps again for O double prime, X double prime, and Y double prime. So extend that line just a little bit more here. Okay, 120. You see that this symbol is going to be similar to one that we've looked at before. This will be somewhat similar to the Mitsubishi symbol. Similar, but not exactly. Congruent. So that's X double prime. Every time we do a translation of an image, we add a prime to it on the superscript. So now I've got Y prime here, and I need to find Y double prime. I'm going to rotate it 120. Z is my last one. Z double prime, that is. Okay. Now just connect all my points here. Of course, O double prime is in the same place as O and O prime. And I'll just write it in here, just to be consistent. It's in here. Okay, and that's it. There's our construction. Of course, if I rotate the double prime image 120 degrees, I'll end up in the original image, or the original pre-image. Okay. So the next one we're going to do, example 4. I like to put tape to hold the paper down. Just put it on 2 corners here. Okay, so example 4, if you were given the figure ABC and its rotated image, A prime, B prime, C prime, both of these are triangles, can you find the center and the angle of rotation? So you can see that this triangle is being rotated to get us this new triangle. So I have a hint over here, and the hint is find the perpendicular bisector of segment AA prime, BB prime, and CC prime. Where the bisectors meet is your center. Okay. So I need the perpendicular bisector of AA prime. So let's make the segment AA prime. I need the perpendicular bisector of BB prime and CC prime. So how do we do a perpendicular bisector? We need to use our compasses. And what we're going to do is we're going to put an arc from one end of the segment, the same radius arc from the other end of the segment, the end point, and then we connect them. And I'm going to draw this nice and long out here. And it doesn't have to be a heavy line, although I hope you can see my line. So maybe I'll make mine just a little bit thicker so you can see it. But I don't want to. The thing is, we'll just end up getting a lot of lines all over the place in arcs. I don't want to be overly confusing. So let's do BB prime now. Make an arc. It needs the arcs. The thing about the arcs is they need to intersect above and below the line. So I don't have to draw the entire arc. I just need to see where they intersect above and below. So I'm going to extend this above. Now you can see there's an intersection here. So where do you think the perpendicular bisector of CC prime is going to be? Let's find out. It's a little difficult to do this because I've got my camera right in front of my face as I'm trying to do this construction. Ideally, you're holding the compass at the top, and maybe your non-dominant hand is holding the point, and you're angling it a little bit to reduce the friction. Here's my intersection. Let's see, where's my intersection? Here. I missed it. Let's see where it is. I gotta redo this one. This one, and this, there we go. Where am I here? Here. Alright. This is what I mean by a lot of arcs. So it's this intersection and this intersection. Okay. So when I draw it, all three go through, they all intersect at the same place. So that's my center right there. We can call this O. Okay, so there's my center. So if I hold this point and move ABC a certain angle, it will be on top of A prime, B prime, C prime. So how do I figure out what this angle is? So the angle of rotation is going to be the angle from AO A prime, or BO B prime, or CO C prime. So all we have to do is measure this angle. So I'm going to draw these lines here, extend these lines. It's this angle right here. This is my angle. All you got to do is one of these, because if you do one of these, it should be the same for the other ones. Okay, so I'm going to put my protractor at the center of the rotation. Okay, I've got it lined up on AO. Now I'm opening this up to OA prime, and it goes through right about here. Looks like right about here. Looks like about 55, 56, 57. Looks like about 57. Looks to round it up just a little bit. 57-degree rotation. Okay, so there's our center and there's the angle of rotation. Okay, very good. I hope that works. I'm going to turn this off now and upload the video.